Hello, you are watching an interesting video about new way to block dengue transmission using the insect bacterium. Please read this disclaimer carefully. Researchers working on a way to block dengue transmission using the insect bacterium Wolbachia to infect mosquitoes have also produced a computer model that predicts how effective the method might be in different scenarios. Dengue fever is caused by a virus that is spread by mosquitoes. Describing their work in the journal Science Translational Medicine, the international team hopes it will lead to better ways to tackle the spread of dengue, a mosquito-borne virus that is a leading cause of illness and death in the tropics and subtropics. As many as 400 million people are infected with dengue every year. The virus, which spreads among humans via Aedes aegypti mosquitoes, causes flu-like symptoms, including intense headache and joint pains. Wolbachia bacteria reside naturally in around 60% of insect species and are probably the most prevalent infectious bacteria on Earth. They live inside the cells of insects, and are passed to the next generation through the host's eggs. For many years, scientists have been studying Wolbachia, to see if they can use it to control the mosquitoes that spread human diseases. So far, this research has found Aegypti mosquitoes stably infected with strains of Wolbachia are resistant to dengue virus infection, and field trials are currently being done to find out how effective this is. Real-world results primed model of Wolbachia effectiveness in reducing dengue spread. In this new study, the researchers carried out a real-world experiment where they allowed mosquitoes infected with Wolbachia and uninfected mosquitoes to feed on the blood of Vietnamese dengue patients. They measured how efficiently the bacterium blocked dengue virus infection of the mosquito body and saliva, which in turn stops them spreading the virus among humans. The team then developed a computer-based model of dengue virus transmission and primed it with the results of the experiment to predict how well the use of Wolbachia might reduce the intensity of dengue transmission in various scenarios. Senior author Cameron Simmons, professor in the Microbiology and Immunology Department at the University of Melbourne in Australia, describes the results. We found that Wolbachia could eliminate dengue transmission in locations where the intensity of transmission is low or moderate. In high transmission settings, Wolbachia would also cause a significant reduction in transmission. Model should help make informed decisions about use of Wolbachia in dengue control. Professor Simmons says their findings are important because they give realistic projections of how effective Wolbachia might be in blocking dengue virus transmission. For example, he says that based on the study results, the recent introduction of Wolbachia in Cairns and Townsville should reduce the severity of future outbreaks of dengue. During the wet season of 2008-09, Australia saw the worst dengue epidemic in over 50 years in these two cities. Professor Simmons, who is also of the Peter Doherty Institute for Infection and Immunity in Melbourne, says, "Our results will enable policymakers in dengue-affected countries to make informed decisions on Wolbachia when allocating scarce resources to dengue control." In December 2014, we reported another study that Professor Simmons co-authored about the discovery of a new class of antibody that could lead to the development of a universal vaccine against dengue. The antibody can neutralize all four types of dengue virus when it is produced from human or mosquito cells. The hope is that the discovery will also improve laboratory tests for dengue. Notes and references.